I think we gave enough time for our guests to have joined in. So let me officially start this webinar on fundamental of EX. So we're going to talk about EX in general, the basics. So let me welcome Bob, our guest, our speaker for today. For those of you that don't know Bob, let me take a moment to introduce him. I hope everybody sees everything okay. Bob has over 30 years of experience in the EX world, and he is a Comp EX instructor as well as an instructor under the ICEX Comp PC scheme. Both scheme is an instructor of, and he's also an inspector and a member of the US ULSTP committee. And he's been working in the EX industry forever, for many, many years. He's a real expert, and you'll be able to listen from him. And we have collected questions through the registration process, which we have a secondary presentation, which we go through at the end of this one. But you are also able to ask questions through the question and answer box that you have in front of you. So let me start with the 5 minutes presentation of the company, our sponsor. Otherwise, I'll get my paycheck at the end of the month. So GM International, what do we do? GM International designs, engineers, and manufactures a complete range of IS and SIL certified devices for most automation packages, from DCS, fire and gas, SCADA, marine, and so on. Used in all industries, prevalent mostly in the oil and gas, but also petrochem, pharmaceutical, fertilizer, mining, food and bev, and so on. We have over 40 years of experience, and we are proud to manufacture all our products here in our headquarters in Italy, where I'm sitting. On the other hand, we have global players with presence in the 5 continents. Next, Bob. All right. Okay, here where we are, we have over 10 offices, direct offices around the world, and we have many distributors. We're about 200 super dedicated employees working exclusively in the EX domain. We also carry on, and lately only online, but courses, EX courses, SIL courses. And these are about our products. We make safety components for our safety industry. So we take special care in manufacturing them, making sure that we use our state-of-the-art technology, 100% product traceability. We do 100% testing. Every single component is tested before I exit our doors. We offer an extended warranty up to 5 years. We provide 10 years availabilities. Because at the end, as you can read there, we're socially responsible, meaning that we care about the environment we live in and the people that work within the factories that we supply to. So customer satisfaction is very important for us, and we care about our product. So next, Bob. To do our job, we need certification. I believe we have more than we need. We have a lot of certifications. Over 15 independent agencies around the globe certify our product. We have TUV, Functional Safety Management System certification, up to SIL 3, ISO 9000, ISO 45000, ROS REACH compliance, SKIP, and a lot of others. And of course, we have a code of ethics, and we have 3TG conflict mineral regulation compliant. And today we have to follow all these rules, but we do with special care. So we have these are the products we manufacture, from IS barriers, safety relays with and without live monitoring. We manufacture also a line of isolator, SIL certified, power supplies, which are SIL and EX certified, multiplexer, arc multiplexer, temperature multiplexer, digital multiplexer. We have a series of termination board or termination panel designed to interface with the most common system out there. SPDs, surge protection device, loop indicators. As I was mentioning earlier, we have a division that carries services in the EX and functional safety domain. Next. This is some of our customers, from system vendors, from ABB to Yokogawa, basically all of them, all the main Mac. Also many EPC we do project with, and many OEM. We're very proud about selling to OEMs because our products are installed in the field. So, like on rigs or trucks, wellhead, and so on. And of course, we are in the AVL of many end users. So here we come to our fundamental of EX. Today, Bob, we are a little now.
Sorry about that. I'm moving the slides a little bit.
It must be that the COVID I went through a month ago, or the heat wave. It's becoming very hot here in Italy. Okay, great, Bob. I'll let you talk. As I said, guys, you can post questions through the question and answer box. We will try to answer them whether through the presentation or at the end. We'll also have some poll in the presentation, so listen in, be careful, because we'll ask you some questions. Okay.
No, thank you, Paolo, and thank you everybody for participating in this. Actually, we are running a class this week in Houston, a Compex training program. So I'm actually we've been spending all week with these guys, and we're going to try to cover basically in the next 40 or so minutes a lot of information to cover in about 2.5, 3 days of formalized training. So some of this may be very basic for you if you haven't been exposed in the EX world. So kind of high level, but certainly if you have some specific questions as we go along in it, please feel free to ask, and we'll try to answer any of those questions as well. At the very end, we also have some questions that were posed from some of the folks that pre-registered that we'll put some of those up and try to answer those as well. So a little bit about the very fundamentals of an explosive atmosphere. Everybody seems to think, and generally this is, pretty much everybody in the world thinks that really the explosive areas, if you will, that we run into are pretty much limited to oil and gas or maybe petrochemical type facilities. But in reality, we see them in all walks of life. Obviously, when we fill up our vehicles with gasoline or diesel, that's a potential flammable atmosphere. We run into this in even pulp and paper industry, the food industry. There's all different kinds of industries in which explosive atmospheres can take place. So it's not just necessarily something that only exists in the oil and gas industry. But we basically break it down and we have to define what are the explosive atmospheres. And they could either comprise of gases and vapors and mist, which is the ones that we commonly think about, the most common. But there's also, again, combustible dust and ignitable solid particles. So we have to kind of understand a little bit about what is it about the hazard that we need to address when we start dealing with and trying to select equipment and address all this good stuff. So there's a key word that we talk about when we talk about EX. Gases and combustible liquids, or I should say, almost every flammable gas, if you will, starts off as a liquid, and then at some point it becomes a combustible gas, if you will. The point in which a liquid becomes a gas, if you will, is a term called flash point. So sometimes you'll hear this term in the EX world. That flash point is actually the point in which combustible vapors will start to form from a liquid. So generally we're talking about combustible gases or liquids, if you will. For example, like liquefied natural gas. The flash point for liquefied natural gas is extremely cold. I think it's minus 200 degrees C or something like that. I may be wrong on that, but it's significantly cold. But once it gets above that particular flash point, at that point, then it becomes a vapor, and at that point, then we really have to be concerned with it. You'll also hear a term that goes along with this called the ignition temperature of the gas. And when we start talking about selection of equipment for hazardous locations, we have to be very concerned about the ignition temperature of the gases and vapors that we're going to be seeing. So there we go. The ignition temperature is the temperature in which the gas will spontaneously ignite. So those are two terms that you hear an awful lot. A lot of people get them confused. So dust, combustible dust can be any of the following type materials. Metal dust, carbonation dust, we find those certainly in coal mining, but we can certainly find those in industry. And then certainly things like flour, grain, wood, plastic, and chemicals. Dust hazards are some of the most dangerous hazards because people just don't think about it. We think about it with regards to petrochem facilities, but we don't necessarily think about it as much with regards to maybe grain elevators or food processing facilities or something like that. But these can be some of the most dangerous explosives and certainly can cause the most damage. And especially when we run into situations where we have a combination of dust and gas hazards in the same environment. And coal mines are a good example where we have actually a combination of coke dust, coal, as well as methane that is generated from the mining of coal. Only dust with stable oxides will not be combustible. One of the things also, metal dusts are also extremely difficult to deal with because not only can they combust, but they're also conductive. And so when we have a metal dust type atmosphere, when we have those types of materials in the environment, when they get into contact with electrical equipment, in many cases, they can short out and that can be the source of ignition. So we have to be very, very careful. So when we're talking about the fundamentals, one of the first things we have to talk about is the explosive triangle. So in order to have an explosion take place, we need to have three things. And this is the triangle that we see, and you've probably all seen this in one way, shape, or form. So we have to have some sort of explosive material, which could be a gas, vapor, dust, fiber flying, what have you. We have to have a source of ignition, and then we certainly have to have it in air. So when we talk about some of the protection concepts, we're basically trying to eliminate or remove one of these legs of the triangle in some way, shape, or form. If we removed oxygen completely from the environment, that makes it very, very difficult for people to work in an environment where there's no air. So that's usually not an effective solution, if you will. Certainly removing the explosive material is ideal if we can, but in many cases we have to put electrical equipment right in those areas in which an explosive gas or vapor or dust is present. So we usually have to focus our attention primarily on that source of ignition. And the sources of ignition in this case could be anything from electrical arcing and sparking, but there's other different sources of ignition that are out there that we really need to take attention into, which we'll talk about. And again, all types of energy can be sources of ignition. So what are common ignition sources? Again, some of these are pretty obvious. Things like exhaust, but hot surfaces, bearings, when bearings fail. But some of the other things that we don't necessarily think about, friction. Friction can actually, and has in many cases, been the source of an explosion. Certainly lightning, if it strikes a particular environment in which it's housing gases and vapors, is obviously catastrophic. We obviously think about open flames, things like fires, cigarette lighters, pilot lights, torches. That's usually the one that everybody always thinks about. But sometimes we also forget about things like mechanical sparks, grinding and cutting. This is why when we do work in hazardous locations, we typically have to have hot work permits or we have to have gas-free permits. But things like even drop tools or equipment, you can actually get a thermite action. So you have to understand what is the materials of the equipment that we're actually building our EX equipment out. There are some specific details in some of the relevant standards out there that say, hey, if we're using a product that has an excessive amount of, say, titanium in its composition, we have to take additional protective measures, if you will, to take that piece of equipment into a hazardous area. So these are all things that we are taking into account that are addressed in some of the EX standards, if you will. Other things like stray electrical currents, static electricity. This is one of the biggest things that is really, I think, jumping up and a lot of people are starting to take much more attention to is static electricity, the buildup of static. Because we actually can build up in many cases, even from air leaks, steam leaks, agitation, stirring, All of those types of things can create potentially static electricity, and it doesn't take an awful lot of energy to ignite some of these gases and vapors. So static is one of those things that has historically been one that people have overlooked, and now we're starting to take a much more proactive approach towards static electricity. This is one of the issues that you find with non-metallic type equipment in hazardous locations. Manufacturers will add things like carbon black into some of their fiberglass reinforced polyester enclosures to address the issue in the buildup of static electricity. We want to limit the amount of surface area of non-metallics to a point to where that static electricity can be able to be dissipated. And that's why we ground so many of these items to make sure that we can bleed off as much of the static electricity as possible. Certainly, radio frequency is also a source of ignition. So taking our telephones, potentially not just an arcing or sparking, but some of the radio frequency, or not so much with telephones, but maybe with transmitters and some of the wireless type products that you can see nowadays. The energy emitted is actually enough to ignite gases and vapors. So we have to be very concerned about when we take or install equipment that, depending on the radio frequency that's actually being used, we have to take that into consideration. And certainly things like batteries, radiation, ultrasonics, exothermic reactions. I think what we may have seen, there was that big massive explosion that took place in Beirut, where they were storing a tremendous amount of ammonium nitrate, which is used typically in the fertilizer industry. Now, it sounds like in that particular instance, they also were housing fireworks, which is not necessarily a good idea. But exothermic reactions are actually one of those things that can generate, can actually just from the chemical reaction itself, that can see a breakdown of the product itself, and then all of a sudden it can create an ignition source. And in the case of, again, ammonium nitrate can devastating results. So we have to take all of that into account when we're doing our hazardous equipment or HAZOP analysis and trying to determine what exactly we need to do to address. Let's see. How come my thing didn't? There we go. Yeah. So as I mentioned a little bit about ignition temperatures, we need to know ignition temperatures of the gases and vapors. And without going into too much detail, these are some of the most common gases and vapors that we'll find in industry that are flammable. So as an example, that first one, hydrogen, we consider that what is called a 2C gas, which is one of the most onerous gases to deal with. We see that it actually has a very, very high ignition temperature, about 560 degrees C. But we find other gases, maybe hydrogen sulfide, which is a 2B gas, which isn't quite as onerous or dangerous necessarily as hydrogen, but in reality, it has a lower ignition temperature. So actually, with regards to heat producing devices, even though we think hydrogen is the most dangerous or one of the most dangerous gases, hydrogen sulfide can be very difficult to deal with because it ignites at a much lower temperature. So we have to take into account the ignition temperatures of these gases and vapors. And this is just a representative sample, but there are literally hundreds of different flammable gases, and with all of their, what they call the ignition temperatures and the flash points, and what you will find are T codes, and these are all referenced within the relevant IEC 60079-20-1 standard, which gives you all the information on all of these gases and vapors. So the amount of ignition energy, since we talked about sources of ignition, how much energy does it actually take to ignite a lot of these common gases? Well, in this case, as you see on the right-hand side, we measure this in microjoules, right? So propane, it takes about 260 microjoules of energy to ignite. Notice that hydrogen only takes about 19 microjoules. So this is a very much significant factor that we have to also take into account when we're selecting equipment for use in hazardous areas, is how much energy does it actually take to ignite these gases? And not all gases have the same amount of energy. And in this case, hydrogen is very, very easily ignited. If we have a proper mixture of hydrogen in combination with air in what is called that flammable limit, it doesn't take a whole heck of a lot of energy to ignite it. Now, this is an interesting chart. That what this is basically showing us here, we have what is called the minimum ignition energy. So the charts that you just saw previously for hydrogen, for example, it shows that the minimum amount of energy was somewhere in, or I should say, it was about 19 microjoules, right, which is just below 0.02. But there's actually a range in which gases and vapors will ignite when exposed in combination with air. And what we're basically saying here is that if we get a rough estimate of approximately 29% hydrogen to approximately 71% air, and if we have the low amount of energy of 19 microjoules, we're going to have an explosion. As we have less hydrogen, more air, or more hydrogen, less air, the amount of energy that it actually takes to ignite it goes up. So it actually, every gas and vapor has what is called this minimum ignition energy curve. And one of the reasons why hydrogen is so dangerous is that it also has an extremely wide explosive range, as a comparison, in this case, to propane. So our first poll
Okay,
question.
Bob. Here's the first poll of the day. Well, I think you mentioned this, I heard it. What is the definition of a flashpoint? Guys, let me, it's on. You can answer. You just click. Nobody will judge you. But temperature in which a gas or vapor will spontaneously ignite. Temperature in which flammable liquid will turn into a flammable gas. Ignition temperature, at which point the gas will explode violently, or the point in which a flammable solid will become a liquid. This last one doesn't sound right. I can give that.
So you're going to eliminate the last.
There's always one answer which is off. When you
Right.
go for your driver license test, you got three. They all look alike, and one that okay, I know this is not funny, but the other three are tough.
Right.
In fact, the first two are very similar. No?
Yeah,
No, very different. Similar but different.
Yeah,
the first one says when will go off, and the second one when will turn into a glass. Well,
yeah.
Let's give it a few more moments for you guys to answer this question. I hope you've been so far so good.
Yeah, paying attention. Good.
You said 20 microjoule, actually 19 microjoule. I was told once that if I drop a pen, that's enough energy to start off hydrogen in the right concentration.
It can, if you have that. So remember, the other thing on that chart that I showed, you have to have a percentage of hydrogen. In that case, I think it was 29% hydrogen to 71%.
Yeah.
So if you had maybe only 10% hydrogen, 90% air, and you drop the pen, it might not. But if you have that right mixture.
But it was trying to make a point that 20 microjoule are very, very little energy.
That is true. That is true.
Okay, let's stop our poll here and let me share the result. The second question got 70%, 60% of the answer. But I believe the first was the correct answer, right, Bob? A.
No, actually, number 2 or B is the correct answer.
Well, then I got it wrong. That's a good one, guys. You did better than I did.
Yeah, no. So the A is actually what a lot of people do think flashpoint is, but A is actually the ignition temperature. So that is.
Oh, okay.
People call it the auto ignition temperature, but we formally call it the ignition temperature of the gas. So as a gas gets up to a particular temperature and it gets, like I said, I think hydrogen, if it gets into an environment in which it's exposed to about 560 degrees Celsius, it will spontaneously ignite. So that's the ignition temperature. The flash point is the point.
Flash point was when liquid turns into gas.
Liquid turns into gas. And here's another thing. The flash point will always be lower than the ignition.
Of course. Always. So a liquid by itself will not be turned. You cannot turn it on. You need to first transform it into gas.
You have to, because if you have a solid vapor, a vapor as a liquid, it's actually, it's not flammable. It's actually the vapors that ignite. So you see that sometimes where people will do stupid things like maybe put gasoline on a bonfire or something like that and then light it, and they go stand over next to the bonfire and then go light it, and then it turns out that the vapors have actually spread because gasoline vapors are heavier than air, and where they're standing is actually where the vapors have accumulated. So when they throw a match towards the big fire, they actually set themselves on fire because it's the vapor that actually ignites, not the liquid. So
Yeah.
just don't do that.
Don't do that.
Don't do that.
Yeah. All right.
All right, continuing on with regards to hazardous locations, this applies to both gases, vapors, as well as equipment. We assign what are called TClass numbers. And these TClass numbers are basically translate into ignition temperatures. So as an example, if you recall what I mentioned about hydrogen, hydrogen has an ignition temperature of 560 degrees. We call that a T1 gas. So any gas that has an ignition temperature of 450 or above is considered to be a T1 gas. A gas that has an ignition temperature somewhere between 300 and 450 is a T2 gas, and so forth and so on. So when we look at selection of electrical equipment for use in hazardous areas, we have to consider how hot a product gets, something like a transformer or a light fitting or something like that. And we'll assign a temperature code to that product. If we assign a T code to a product, that means that, as an example, if we had, say, a motor starter that was rated T5, that means that the relevant surface on that motor starter will never exceed 100 degrees C, under the maximum ambient in which it's intended to be used for. So we can use a product that's marked T5 into an environment in which the gas is also rated at T5, because the gas will be higher than the ignition temperature, but the product will actually be lower, if that makes sense. Hopefully it.
Is there gases? What type of gases have T6? I mean, T6 is very, very low. Are there
There's
products rated for T6?
There is one gas, and I knew you were going to ask me that, and I said it yesterday, and I can't remember the name of it. It's one gas out there, and it's actually has an ignition temperature of 90 degrees C.
Okay.
And
Because most products are certified T4, T5, right?
yes,
But,
and
but
most,
if you have a T6 gas, you need a T6 product. Else you cannot
that's
install a
correct.
T4 product, certified T4 into a T6.
That's right. You can use a T6 product in any environment. You can use a T1 product only for a T1 environment. So yes, the best product out there is a product that's rated T6. Most of your industrial gases and vapors that are flammable will be rated somewhere between T3 and T1. They usually have an ignition temperature of above 200 degrees C. But there are quite a few gases and vapors that are below 200 degrees C. But there's only one that is actually below T5, and it's
I
a
might check it online.
yeah, yeah. Oh, I'll be happy to tell you what it is. I just can't remember it right this
But
moment.
no issue, no issue. But guys, if you have a T6 gas, you need to look for a T6
Ah,
product. Else
there
you
it
cannot
is.
install it.
The
Oh,
next slide
there it
had
is.
it. The next slide had it. Carbon disulfide.
Carbon disulfide.
Yes, carbon
Okay.
disulfide is actually the only gas that's actually rated at T6. It has an ignition temperature of 90 degrees C.
So in
So
T5, there are no gases in T5?
no, there are. It's just these are just some of the real
The
common,
most common.
the most common ones, right?
Okay.
So if you notice, a lot of the gases and vapors are actually somewhere in the T1 to T2 to T3 range.
We are in our domain here in oil and gas, T1, will probably be most of them, T2 also.
Most of them
Ethanol.
are, yeah, it's T3, T2, T1. The real common one, you think about things like ethane, propane, hydrogen, methane, those are all T1 gases. You know, ethylene, T2, acetylene is a T2. But then there's also things like jet fuel, uh, heptane, kerosene are T3 gases. So you can find anything from, T1 to T3 in most of these petrochemical facilities. So this chart kind of explains a little bit what I just mentioned, and I'll just kind of read a little bit from the back down or halfway down. It says, as an example, a product that carries a T4 rating will state that the product under the maximum ambient, and every EX product will have an ambient range. The default for any EX product, if it's not marked, is -20 to +40. Now, in many parts of the world, we run into situations where +40, it gets hotter than that. So we have to make sure that we select the product that's suitable for the ambient. But the T code will be based upon the maximum ambient that that product can be used in. So in this case, a T4 gas will have an ignition temperature above 135, but below T3, which is 200 degrees C. The product itself will never get to 135 degrees C. So therefore, we can use a T4 product into an environment in which T4 gases are present, if that makes sense.
And then you have correctly mentioned, the product certification matters as well. So if a product is certified for plus 60 degrees T4, it means it will be within T4 limits if it's used up to 60 degrees.
That's
If you put
correct.
them in 80 degrees, well, then that T4 is no longer valid. So
That's
it's
right.
something to take
And
into account.
you're absolutely correct. And you'll see products that will actually be marked with multiple different T codes based upon the ambient in which they're used. So you might see a product that might have a let's just say a T4 rating at a 40 degrees C ambient. But the moment that we take that and we put it into a 50 degrees C ambient, then all of a sudden, of course, that product could potentially increase by at least, 10
At
degrees.
least, that 10
Yeah,
degrees.
and that could push it up to maybe a T3 rating. So it's really important when we're selecting equipment to make sure that number one, the product is suitable and certified for that particular ambient, and then also making sure that we're selecting the product that has the appropriate temperature code. So keep that in mind. So some of the other factors that go into the area classification is the density of the gases and vapors. So a lot of times people wonder, if you pull into a petrol station, a gas station of some sort, and you look right above you, and gasoline vapors are extremely volatile, flammable. But you'll actually see that gasoline vapors in this chart are heavier than air, meaning that as we start to fill up our vehicle, any of those vapors are going to go to the ground. So when you do area classifications for, say, for example, gas stations, you'll find EX equipment maybe near the ground. Inside of the pump unit itself, there's actually some EX equipment, but yet the lights right above you, because gasoline vapors are heavier than air, as soon as they start rising in any way, shape, or form, they get dissipated by the air. Therefore, we can say that, hey, we don't have to have EX lighting at a gas station. On the other hand, if we have hydrogen inside of a room, hydrogen being lighter than air is all going to go up near the ceiling. So this is also an important thing when we start talking about pressurized enclosures, where we actually have to have intake and outtake when we design EXP equipment. We have to take into account the density of the gases and vapors. And one of the reasons why acetylene is so dangerous is actually it has the same density as air. It's very close. So wherever air goes and acetylene gets released, that's exactly where acetylene will go. So acetylene is a very, very dangerous gas. It's one of the most volatile gases, high pressures when it explodes. It has a high ignition temperature, but it's also, the density is very close to being at 1. So if it does get released into the atmosphere, it'll go everywhere. So this is kind of a little bit of an example here. So if we were trying to figure out where we needed to place some gas detectors in a facility, if the gases and vapors are heavier than air, then they're going to, we have a gas relief from, say, some sort of flange of some sort, then we'd probably want to put our gas detectors in the low areas within our facility. Obviously, if the gases were released are lighter than air and it's indoors of some sort, then we'd certainly put our gas detectors at different locations. So it's important to understand the density of the gases and vapors based upon where we're going to actually place our EX equipment. And sometimes this also helps us from making determinations of where we should be placing it, because ideally, we want to try to place our EX equipment as far outside of the area in which a flammable gas air mixture could be. So maybe we mount things higher, lower, depending on the gas or the density of the vapor and how quickly it can spread. And of course, if it had the same density, we'd probably put it really close to actually where it is.
Well, we spoke a lot about T code just a moment ago. So here's a question for you guys. What would be the T code for a product that has a maximum relevant surface temperature under normal or full condition of 125 C? So,
It's a tough question. This is not easy.
well, I saw well, at first answer was correct. I don't see, you see the answer, I see the answer coming. So you guys are doing okay. It is, but we talked about 90, 80 something at the bottom and 500 at the top. So
Yep.
125 somewhere,
Somewhere in there, right?
somewhere in there, not too far up, not too far down. Maybe
I will, I will,
right.
I will, I will give you a hint here for those of you
Okay.
who have not answered. So T6 translates to 85 degrees C.
Okay.
T5 is 100 degrees C. T4 is 135 degrees C.
Well, you gave the answer already then.
T3 is 200 degrees C. And T2 is 300 degrees C. And T1 is 450 degrees C. So if that
yeah,
helps.
well, all votes from now on don't count because Bob gave you the answer. But yeah, let me stop it right here so we can continue. Otherwise, we lose a lot of time today. So yes, it's T4. Most of you got it correct.
Yep.
Which is, by the way, the certification we get for all our products. All our barrier are T4 certified. Okay, stop. I haven't shared the result. Here we go. Now you see it.
Oh,
And now you see it. And now you don't. Let's move on. Yeah. Because well, we're running into
yeah.
40 minutes into our presentation. We're still at page 29. I know there's a poll at page 40, so we got a lot of pages to go.
I'll zip through this. I won't go through this slide in complete, but basically we classify gases and vapors and dust into what are called zones. And so there's what is called zone 0, zone 1, zone 2. And this all has to do with the frequency and the duration of the gases and vapors. The standard that we do area classification to is the 60079-10-1. But there's also other standards around the world that we can follow. Here in the United States, we use NFPA documents. So we use API recommended practices. So without going into further details, I will kind of skip this. And by the way, all of this information is available on YouTube, and these wall charts, this information is actually from the GMI wall charts. So if anybody here would like to get a copy of these wall charts, you just contact either Paulo or myself. We'd be happy to get these to you.
Sure.
And be happy to explain all this good stuff to you.
And also, we will share a copy of the presentation to you guys, those
right.
who have participated.
This is one question because I know a lot of you are probably potentially customers or are customers of GMI with regards to intrinsically safe barriers. So barriers are actually, there's what is called an IA barrier, an IB rating, and an IC. The GMI products are rated as IA for the most part, and these are considered to be very high to fault tolerant. So they actually have some redundancy built in. So when we're talking about EX equipment suitable for high risk areas, we actually have to have a very high to fault tolerant type design. So that's where you find intrinsically safe barriers are typically one of the only protection methodologies that are approved for zone 0 environments. And zone 0 is an environment in which the flammable gas air mixture is going to be present pretty much continuously. So
one more poll question right away. This looks like a tough one, Bob. What would be the definition of zone 1 under 60079-10-1? A place where a gas, vapor, hazardous atmosphere is present frequently or continuously. Place where a gas, vapor, hazardous atmosphere is present occasionally or occasionally during normal operation but occurs infrequently, or only during or present occasionally during normal operation.
That's a mouthful.
Yeah, it is a mouthful. I didn't read it more because I don't want to. You can guys read it.
Yeah.
My English is what it is.
And this is actually a question that you will see in Compex and under the IECEX competency scheme. This is
Yeah,
something that's
for
pretty common.
certification.
Yeah, yeah. So this is the kind of information that you would want to have in your noggin to make sure that you understand
Well,
before you.
zone one, 60079. Yeah. So we could say there are three zones in under this scheme, right? You have zone 0, zone 1, and zone 2.
Yep, but we have four answers.
Yeah.
Well,
So
what's the issue? One
yeah.
of them, one of them, I will tell you right now, is not the answer, and nobody has answered this one. It's D, because the question was zone one, and zone one only applies to gases and vapors.
Yeah, I didn't realize that. You're right. That's dust. So
That
yeah, you're right.
So that would be zone 21 or
21. Yeah.
21. So
So it's one of those three. And if I take you, Bob, for make it super fast, you wrote down the three zones 1, 2, 3 in the sequence they are in the standard. Maybe not.
yeah,
Is present frequently or continuously, is present occasionally, is present infrequently. Well, I'll give you my answer. My bit is B.
you're correct.
I am correct. Okay, well, I'll end the poll now. So let's see how our guest did. It is, yeah, B. Most of you answered B. So it's
That's
correct.
that good. Fantastic. Most of you got that correct. So yeah, if it's continuously, we call that a zone zero. If it's in their normal operation, that's zone one. And if it's occasionally, but it's infrequent, we consider that to be a zone two environment.
Okay,
Right.
great.
So we'll zip through a little bit of these protection concepts because again, this is information that we cover in about 2 to 3 days. So we'll cover it in 2 to 3 minutes. Uh, but there are basically four main concepts of how we protect. First is energy limitation, which we would commonly refer to as intrinsic safety. Non-sparking, which is commonly referred to as increased safety. Containment, flame-proof, sand or quartz filled is a containment method, or separation. Pressurization is a good example, or oil immersion. That's where we're separating, in effect, the flammable mixture from the source of ignition. So the specific details on these concepts are all listed under the 60079 set of standards, and you see on the right-hand side which standard applies to which protection method. One question that people ask is, what standard should I be following for the design and installation of EX equipment? If we're doing it to international standards, we should be following the 60079-14 standard. That's of all the standards to get your hands on, that's the one that's probably the most important for designers, engineers, installers, because this tells you what you can and cannot do with regards to EX equipment. So energy limitation, we limit the amount of energy. That's our minimum ignition energy, kind of like what we talked about previously uh, for hydrogen. For example, we saw that it was 19 microjoules. So a barrier that is rated for hydrogen applications cannot allow more than 19 microjoules. And actually, there's a safety factor built in, so it actually is going to be significantly less. So we have, again, three fault tolerance range: EXIA, IB, and IC. Increased safety is considered to be a non-sparking. So if we have no sparking going on inside of an enclosure, then therefore the enclosure doesn't need to be flame-proof or contain an explosion. So that's an example of using increased safety terminals. And we have certain creepage and clearance requirements that we have to abide with regards to doing this. One thing that has changed, if you're familiar with the old EXN standards, many of those have actually disappeared. For example, EXNA is now called EXEC, and that information is now in 60079-7, which is the increased safety standard. Containment, again, flame-proof. We also have powder-filled enclosed brakes. They contain the explosion and do not allow the hot flaming gases to ignite the surrounding atmosphere. So this is very commonly referred to as EXD. And then separation, again, we could do it encapsulation, hermetically sealed, pressurization, restricted breathing. So all of these protection concepts are used in industry. Some are more popular in some parts of the world or for certain applications. As an example, intrinsic safety, every now and then somebody will ask, hey, can I make a motor starter intrinsically safe? Or can I make a light fitting intrinsically safe? Well, generally no, because you require more energy to actually operate than what is allowed under the use of intrinsic safety. On the other hand, it makes sense for transmitters and thermocouples and RTDs and solenoids that protection concept, intrinsic safety makes great sense to use. So we really have to understand what product it is that makes sense to go back and see what are our options with regards to the various protection concepts. And also understand this, not all protection concepts are suitable for all zones and gas groups, T codes, and specifically the ambience as well. So there's a little bit of engineering and design work that we need to do up front before we start selecting equipment for use in these areas. Markings, I won't go through all this good stuff because we're running out of time, but basically what you see, and I'll just try to draw on this a little bit if I can. So that information, what you see right here is our ATEX directive marking information. So what you see, we have the CE mark that's telling us, and by the way, if we see a CE on a product, that doesn't mean that it's suitable for hazardous location. It just means that it has been, well, not necessarily, the manufacturer has declared that their product is suitable for the European market. But if we find this EX and the CE, along with the 4-digit number, that means there's actually been some sort of certification around this. Could be self-declared, but that's compliance to the ATEX directive. Equipment group is Roman numeral 2. Category, and 1G, what we see right here, basically means the exact same thing as what is called GA. 1G is telling us that this product is good for a gas environment. Into 1, that means it's actually suitable for a zone 0 environment. Then over here, what we have is our EX mark. In this case, it's intrinsically safe. That's our gas group, and there's our temperature code. And again, our equipment protection level, which is a requirement under the IEC EX. So this marking that you see right here is the marking that you will find on a piece of equipment that only has IEC EX. This is the marking that you would find on a product that has ATEX. So
you're going to CE marking. Basically, CE marking means that you are declaring that you are compliant to all the regulation and laws that apply to your product within that device. So in this case, ATEX regulations.
And by the way, one very, very important thing, and we actually was talking with some students here this morning about this, is I highlight this very much so. It's the X condition. Anytime that we see an X at the end of the certificate, what that means is that there's a special condition for safe use for that particular piece of equipment that we need to look very closely at the certificate to tell us what is it about that condition that I have to make sure that when I'm installing it, that I follow. Because I go in and do inspections and I'll take a look at equipment and I'll see an X on the label. Well, I need to have a copy of the cert because the cert will tell me that information. And then I check and find out what is it about the conditions for safe use and have you installed it in accordance to the conditions for safe use. And if
an example of that is our barriers, which are T4 certified. Then there's an X, and you look in the X, it says this device must be installed into an enclosure, which is minimum IP54 certified. It sounds obvious, it's a device by itself. You cannot just put it in the field, but it's a condition. Maybe you put in an IMA, instead of an IMA 4X or 4, you put it into lesser tight enclosure. Well, you might have a problem.
Well, Paulo, my screen has just absolutely locked up.
Well, you were locking up earlier now, but you're okay. We see the screen. Can you move forward in the slides?
I can't move forward. I don't know why. I'm trying. Something is
Well, let
happening.
me take control of the slides.
That
Uh,
sounds like a great idea. I don't know
request, see if you can give me control.
if I can do that. I think I can.
Okay, I think I have control. Okay, sorry guys.
Yeah, apologize. I don't know what happened here. It just, I
Okay,
checked my mouse. Maybe my battery died.
okay. How do I move forward? I see the, okay, here we go. I move to the next slide. Can you
Ah,
see it, Bob?
I can see it. I can see it. So
Okay.
this is the marking that you would find typically on a barrier. Um, so you'll actually see a couple different marking strings at the very, very top on the left-hand side. You'll see a Roman numeral 2, a 3, a 1 in a bracket, G, so forth and so on. So what that's actually telling us is anything that's not in a bracket or parentheses is telling us where it can be installed. When we see it in brackets or parentheses, that's telling us where it's providing protection to. So in this case, what we're actually reading there is that this barrier, if you will, can be installed in a zone 2 area because the protection concept is NA, but it's providing protection downstream into a zone 0 using intrinsic safety, reference IAGA. So that is the normal marking that you would typically find on a intrinsically safe barrier. So it can get very, very confusing. But these are the kinds of marks that you will typically find on your piece of EX equipment.
Why can I now move forward?
You can't either.
I'm trying to maybe use the roller. This is not a good day, huh? So annotate, close annotate, and why don't I try to give it back to you? See if you now have control. Try.
Okay. Have you? Nope. I don't know what has happened. Maybe
All
Zoom
right.
is.
Well, give it back to me, and I'll try to move forward. Guys, sorry for this inconvenience. Okay, we go. This is
Did I do
another example of EX marking.
that? Did you do that or did I do that?
I think you did it.
Wait a minute. Oh, something's happening.
All right.
Well, I tell you what, we're running out of a little bit of time, so let's skip the polling question,
Okay.
and we'll just go ahead and do this. How's this? Oops, I am able to move a little bit here. So one thing that we have not talked about, and I would highly recommend, functional safety is related into the EX world. And so for those of you who are interested in that, GMI has some wonderful videos and webinars on this topic, and certainly provides formalized training around the functional safety fundamentals program. We also, in conjunction with GMI, offer the IECEX Certificate of Personnel Competency Program for any of those individuals that actually want to get their certification around that. So we have both the SIL charts as well as the EX wall charts available, and we would be happy to get those to you. And, oh, I went too fast. Here's the important thing to remember with regards to EX, and this is the one thing that I always tell people. A lot of times, depending on the group of individuals I'm talking to, we could have designers, we could have installers, we could have users, we could have maintenance people. The important thing to remember is, it's only as good as the weakest link with regards to EX. And we all take responsibility in making sure that it's right. So one of the things I tell all the students, if you don't think it's right, speak up. We don't want to wind up with a major industrial accident like what we've had in the previous years or so. So we're only as strong as the weakest link. Make sure that we're on top of it. Get educated, ask questions, learn, read, and we all get better when we all share information.
So Bob, as I will, we have a couple of live questions here. While I share the presentation for question and answer. What is the construction difference between EXE and EXNA?
So yeah, that's a good question. So EXE, the requirement was for EXE enclosures. And by the way, I don't know if you can see this little screen thing on mine, but anyway, I'm seeing you, Paulo.
Do you see the presentation I'm starting to share or not?
Yeah, I actually do. I am seeing it.
Good.
So okay. Um, so EXE is to be able to withstand. Basically, the main difference is the impact resistant requirement of EXE versus EXNA. It's a 7 joule impact requirement for EXE, where it's a 3.5 joule impact resistant test for EXNA. And so what's happened is that EXNA has now become what is called EXEC. The legacy EXE will now be known as EXEB.
Okay. Here's one question that we received through the registration process. Can we open a JB, junction box housing barrier in a running plant if JB is in zone 1 or zone 2? Do we
No,
use normal tool to do so or special tools?
yeah, you cannot open, well, now I see barriers. Yes, I mean, the standard, here's the thing.
Yes.
Many companies do not allow you to open up anything while energized or without a hot work permit. So what I'm going to tell you is that the IEC standard, the 60079-14, does allow you to open them up in a hazardous area. But, and that's strictly for circuits, intrinsically safe circuits. That being said, if we had a junction box that is housing some barriers that is providing output, and the barriers themselves are suitable for zone 2, but the input on the other side of the barrier is actually considered to be general purpose, we could not open that up in a hazardous area.
Okay. Next, why EXD are frequently found rather than EXE in the marketplace, even though EXE has many benefits in zone 2, for example, maintenance during process, easier assembly, lesser cost, and so on.
Yeah, so EXD has been around quite some time. EXI, intrinsic safety, and EXD were two of the first protection concepts. So EXD is actually, and it's people understand it. We put a lot of electrical equipment on the inside of it. It's general purpose equipment. We basically house it in a big housing, cast housing, and we're done and dusted. So people understand it. I think increased safety. Part of the issue is that we cannot put any arcing or sparking inside of increased safety equipment without further protection, meaning that if we wanted to put a relay inside of an EXE enclosure, that relay would have to be certified. Or if we put a contactor on the inside of an EXE enclosure, that contactor would have to be EX certified. So EXD allows you a lot more flexibility. It allows you to use general purpose equipment in a hazardous location. Um, but people do like using EXE, and 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 I think it's just preference. You know, as time has gone on, I think EXD was by far and away the most common technique out there, but people are looking for alternatives, lighter weight, less bolts, easier maintenance. So EXE is certainly you're finding more and more products in the marketplace that are available EXE. So
How about the EN 50495 standard? How is this relevant to our business?
yeah, actually, yeah, I forgot about this one. Yeah, if you go to the next slide, the answer is actually on the slide. If I'm
Right
not
here,
mistaken.
okay.
Yeah, so there
There's
is.
a couple of slides on this.
Yeah, so this had to do specifically with regards to electrical equipment in hazardous areas being controlled or affected by equipment outside of the hazardous area. So, or other pieces of EX equipment within that area. And so the example is an EX motor with a contactor. And are we making sure that the trip settings on, say, for example, our contactor are making sure that they're set appropriately for the motor to make sure we take it offline so it doesn't overheat and potentially create an explosive hazard. That's one example. There are other ones as well.
Okay, we are running late. Let's answer a couple more questions. How about if we house in an enclosure several type of EXE equipment in zone 2? What is the
Yeah.
explosion protection method we have to use, or the type of enclosure we have to use?
So I think if you go to the next slide, I think it shows. Yeah. So EXE equipment might be the enclosure. For example, the picture of the one on the left-hand side that has some operators, push buttons, selector switches. The contact blocks themselves would be rated EXD. Over on the right-hand side, it looks like we have some power supplies, we might have barriers, we might have relays, and all of those products would actually have to be certified if we put them into an EX box, an EXE enclosure. Those would actually have to be certified in some way, shape, or form. So most likely the one on the right-hand side would be Zone 2 rated, and we would say that would be an EXEC rated enclosure, as long as all those components were rated for Zone 2 individually.
So the component themselves must be certified for the area along with the enclosure.
That's right. Now, just as an option with that, say, for example, if you had some products that were not Zone 2 rated and you wanted to put them into a Zone 2, then you could go with what is called a pressurized unit, and you'd pressurize that enclosure using some sort of inert non-flammable gas. So that would
So
be,
you turn it into a safe area, basically.
you would in effect turn that into a safe area. Yeah.
Well, about humidity and corrosive atmosphere environment, I'm sure you have had a lot of experience with that in your inspections.
Yeah. Yeah. So it is absolutely very critical. When we do inspections of EX equipment, there's a really a maximum time frame in which EX equipment shall be inspected. And it's about 3 years. But we will find that in certain environments, we might see things that, quite frankly, will be destroyed within a year. So we have to select the appropriate equipment, install it in the appropriate fashion, make sure it has good ingress protection codes, make sure the materials are appropriate for the environment. So yes, absolutely, we need to pay close attention to high humidity as well as saltwater environments or a particular corrosive agent.
All right, we are a few minutes late, but we have a question here that we get all the time. We are interested in a blah 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 or webinar on safety relays or what have you. So just go online, look at our live webinar schedule, where you can also see all our webinars that are being recorded, and this one also will be on our YouTube channel. Now, to conclude, let me launch the last poll, if I manage to do so. Poll, just let us know how we did. Okay, here we go. Of course, our Bob did, because Bob is running the show. Yeah. I see there's a couple of questions. Let me see. What type of cooler do you suggest for every hot environment in the Middle East?
What type of cooler?
Cooler do you suggest for very hot environment? I mean, I imagine there are
Yeah. So
EX certified coolers, right?
well, there's more heaters than there are coolers. Typically, what people will do is will try not to mount it in an outdoor location. So there are HVAC manufacturers that make EX HVAC. They're usually bigger units, so they're not necessarily for panel mount type app. I mean, there are some that do make some panel mounted units, but they're usually pretty big. There's kind of an area there that I would say vortex cooling. There are some vortex coolers where you're forcing in a cool air, but that generally requires the use of purging and pressurizing concept. So
Typically, and small panel is very difficult. Sometimes they get this spray painted. They say they reduce the heat inside. Whether that works or not, I'm not 100% sure. But
yeah,
anyhow, guys, let me end the poll. Thank you, guys. Thank you, Bob.
well, thank you, Paulo, and I apologize for my computer acting up as it did, but hopefully this was worthwhile.
Okay.
You learned something.
We'll see you next time, and keep safe, keep well. And for all you guys, thank you for being with us, and see you again. Check us on our website, Next time, me and Bob will be together. Or check our Tino's, Mauro's, all our other panelists. Okay,
Right.
ciao.
Ciao. Thank you so much, everybody.
Ciao, ciao.